Anybody have questions about the homework?
I did.
All right. Anybody got questions about the homework? Yeah. Yeah, I don't. Oh. All right, I think it's time. Did you have a homework question? Yeah. Let's get it started. I hope you've had a chance to check out the homework. It's posted at the class website, which is, you can follow the link on the syllabus, this thing here. It's not on Blackboard because I don't like Blackboard. I just put it on my own website, so check it out. The homework is due tomorrow at midnight, so hopefully that will be enough time. Please let me know if you have questions. I'd be happy to chat about it. Let's get to it then. We were talking about the ranked choice voting, right? I wanted to do I wanted to try the ranked choice on this example handout thing that that I gave you last time. If you don't have it, it's fine. I'm just going to write the chart again. Let's try the ranked choice voting for that. This was an election with 37 voters, and in case you don't have the paper, I will tell you again what the votes were. C, B, D, A. All right, so 14 people said A, B, C, D. 10 people said C, B, D, A. 8 people said D, C, B, A. 4 said B, D, C, A. And 1 person said C, D, B, A. All right. this was the votes as cast. And I want to find the winner using the ranked choice. So I hope you recall how to do this. You do rounds where in each round, the person with the fewest first place votes is eliminated. So in round 1, I count up only the first place votes of each of these candidates. It looks like A gets 14. That's right here. 14 people put A in the top spot. What about B? I see 4 for B. So B gets 4. C gets 10 people put C on top here, plus another 1 person over here. So that would be 11 votes for C in the top position. And then D has 8. All right. This is actually what you do if you are using the plurality system. You would just look at this, and that's the end. You would say A is the winner. But the ranked choice doesn't stop there. So A is the winner for the first round, but that doesn't really matter. We eliminate the person with the fewest number of first place rankings, and that is B. So B is eliminated. And then in my list, I'm going to recount everything as if B was missing. You know, in the real world, you don't actually have to get people to vote again. You're not redoing the election. You are just counting the votes again with B missing. So if B is eliminated, maybe I'll just kind of cross out all these B's. All right. And now I count up the results again in round 2 now. Now it's just between A, C, and D. And all of these votes right here, this is the interesting column here in round 2. All of these votes, they used to have B on top. Now they're going to be counted for D. This is why sometimes when people describe the ranked choice, they say, if your favorite gets eliminated, then your vote automatically will transfer to your second place. And that's what happens. These 4 people count for D. So again, A has 14. And C has 11, just like before. It's this 10 plus this 1. But now D has 8 from here plus 4 from here. That's 12. So this is 8 plus 4, which is 12. All right? I hope everybody remembers how to do it. And so who gets eliminated? C. Yeah, the C has the least at this point. So I eliminate C. And then finally, I go to round 3. Now you could cross off the C's. Maybe at this point, once I have a lot of like crossed off bits, I like to just redraw everything, although you can do it however you like. I cross out the C's. Now it says 14AD, 10. Now it says DA. I'm just redrawing this stuff, but without the B's and also without the C's. The next one says DA. So this is 8, DA. 4 is DA, and also 1 is DA. All right. And now I count up the results of this one. So this is round 3. In the final round, it's only A and D are remaining. And it looks like A has 14, D has all the others, which is 18, 20, 23. And so D is the winner. Dwins. All right. This is how we do the ranked choice voting. I hope that that makes sense to everybody. Anybody got any questions for that? So this is an example where you can see pretty clearly the ranked choice the ranked choice winner is not always the same as the plurality winner. If we do the plurality system in this election, we did this last time, you can just see from the first round here, A has the most votes in the first place. So in this case, A wins with plurality, but D wins with the ranked choice voting. All right. Sometimes the ranked choice winner is different from the plurality winner. All right. The ranked choice is a little bit more sophisticated, I hope you agree, and it can sometimes make choices in a way which the plurality can't. Like, for example, the first time we ever looked at this chart here, I asked everybody to say, you know, who do you think should be the winner? And from the very simple point of view, you could say A should win because they got more votes than anybody else. But if you look a little more carefully, you will notice that actually everybody else really hates A apart from these 14 people. So maybe there's some reason why A should not be the winner. And if you use the ranked choice in this case, the A actually will not win because A is actually worse. You can see that very clearly right here. By the time you get to the last round, you realize that everybody else hates A and they like D more, and which is why D became the winner with the ranked choice. All right, that's the purpose of the ranked choice. It's meant to be a little more sophisticated and better at making the decision than plurality. All right. Although, of course, this is, it's controversial when you ask people in real life, should we use the ranked choice or the plurality? Not everybody agrees that the ranked choice is better. It is, I would say, it is something we can all agree on. It is at least mathematically more sophisticated than the plurality. All right, let's look just for fun. Can we look at how the ranked choice would have decided the Bush-Gore election? Bush-Gore Nader. This is a real-world presidential election that we mentioned last time. The Bush-Gore Nader election, this was the state of Florida in the year 2000. The votes as it was in that election was basically 2.9 million people said Bush, Bush, then Gore, then Nader. This is making some assumptions about people's actual preferences because in real life they didn't write down their preferences. But it's fair to assume that the people who voted for Bush would have preferred Gore over Nader because Nader was viewed as the extreme liberal outsider. And then 2.9 million people who put Gore on top. Let's just imagine, this is not an accurate assumption, but let's just imagine they all would have put Bush in the second position. This is being very favorable to Bush. In real life, they would not have favored Bush so hard, but let's just, being charitable to Bush, let's give it like that. And then the last column, 0.1 million. I'm just rounding everything to the nearest 100,000, I guess, 1/10 of a million. These people said Nader, but would have preferred Gore over Bush. All right, these are the preferences that we can fairly confidently assume. Apart from the middle there, I'm giving the benefit of the doubt to Bush. All right. Anyway, what would happen if we used the ranked choice? Now, with the plurality, which is the way it actually went down in real life, it looks like a tie between Bush and Gore having the most. But really, this number is very slightly more than this number, and so Bush was the winner. But let's see what would happen if we do the ranked choice. So do the ranked choice voting. In the round one, I count up. Bush gets 2.9. Let's just count in terms of millions. Gore, see that's here, right? 2.9 million people put Bush on top. Gore, how many votes did Gore get in the top position? I heard somebody whisper, 2.9. Yes, also 2.9 million people voted for Gore in the top position. Looks like a tie. It doesn't actually matter. In the ranked choice, tie for first doesn't make any difference. And then how many people put Nader in the top? It's 0.1. So 0.1 million people put Nader on top. Who is eliminated? Nader is eliminated, sort of as he should be, right? Very few people actually wanted Nader to become the president. So Nader is eliminated. And then we go to round two. In round two, I'll just redraw the chart. 2.9 million people, this time without Nader. 2.9 said Bush Gore. 2.9 said Gore Bush. And then the other 0.1 said Gore Bush when you remove Nader. All right. And now when I count them up this time, I see Bush has, again, only 2.9 million. But for Gore, all of those Nader votes would be transferred to Gore. Gore now has 2.9 plus 0.1, which is an even 3.0. And so Gore wins. All right. If we had used the ranked choice in Florida in that election, Gore would have been the winner. All right. Now, like I said, I'm making some assumptions when I draw this chart, but really in the real world, everybody else would have been eliminated until the last round would have been Gore versus Bush, because there's no way Nader was going to make it to the last round or anybody else. So they would have made it to the final round between Gore and Bush, and more people preferred Gore rather than Bush in the state of Florida in this election. And so Gore would have won if they used the ranked choice. All right. Because of this is like the most well-known example of an election where people think that the plurality system messed it up. And because of this and some other high-profile cases, if you read about ranked choice these days, some people will present ranked choice voting in politics as some kind of a scam to help Democrats win. They think that the people who are trying to change to ranked choice are just sort of butthurt that Bush won this election, and they're so upset that Gore lost that they want to change the way that we vote to make it so that Gore would have won. This is I don't judge people's motivations. I think it is a fact that if we in the United States today changed all of our elections to ranked choice, it would probably favor the Democrats and hurt the Republicans. So there's always some there. When I hear people in real life saying, like, especially politicians saying, "I really want to change to ranked choice," it could be because they think that it's truly a better democratic system, or it could be because they think that it's just going to help them win more elections. To me, changing to using ranked choice because it's a better system is a good reason. Using it just because it's going to make me win the next election is not a great reason, in my opinion, because I'm not a politician who's just trying to win at all costs. I kind of, just to like tip my hand a little bit in terms of the real world, I kind of like ranked choice. I feel like it is mathematically more sophisticated than plurality, and it can judge better what people's actual opinions are. Like I do, my own political opinions aside, I do believe that Gore should have been the winner in this case. If this was an election where more people liked Gore than Bush, it doesn't make sense to me that Bush can be the winner, right? Now, I understand, according to the rules of how we do elections, Bush was the winner. So I'm not, I don't cry myself to sleep about it, but I do feel like a more mathematically sophisticated system might be better at choosing the winners. Although it's a super partisan issue in the real world today. People who say that ranked choice is a total scam are probably not being honest, like mathematically. And also people who say that ranked choice is like going to save all the problems that faces our nation are also, in my opinion, probably not being honest about it. All right. Let me just talk about a little bit in the real world about the plurality system versus ranked choice, but really I want to just focus on the plurality system. So in the United States, and actually most places in the world, we generally use the plurality system, right? That is, nobody ranks their choices. They only say, who is my favorite, and that's it, all right? And then all that they do when they count is just count up how many people said, Bush was their favorite, how many people said Gore was their favorite, how many people said Nader was their favorite. This is the plurality system. There is a major effect of the plurality system that shapes basically everything that happens politically in the United States. And that is that in a plurality election, your vote really doesn't count for much unless your candidate wins, all right? I'm going to say it this way. In a plurality election, voting for the loser has no effect, all right? Your vote only counts, I'll say your vote only matters if your candidate wins. Because of this, people in America, this is a very common phrase that you hear about the fact that we have, the two parties in America, the Republicans and the Democrats, and basically everybody has to choose between you have to choose either the Republican or the Democrat. Now, that's not true by law. Like, you could decide to vote for your mom, or you could vote for Nader or somebody else, but the response to that attitude is that you might as well throw your vote away if you're going to vote for Nader, because he's not going to win, and so there's no point in even voting for him, right? Your vote only matters if your candidate wins. The effect is, in the United States, I will say this makes everybody, or almost everybody, vote for the D or the R, the Democrat or the Republican, all right? When there's a presidential election, basically everybody is voting for, the Trump or the Biden. They're not going to vote for Nader or whoever else is further down on the ballot. There are other candidates on the ballot, but nobody votes for them because, I will say, voting for an outsider is, the common phrase that people use for this is throwing your vote away. I know a guy who every presidential election votes, he writes in Bob Dylan. This is not a serious mathematical vote, I would say, with due respect to this guy.
Is Bob Dylan still alive?
Yes, Bob Dylan is still alive, yeah. He just won the Pulitzer Prize or something a couple years ago. Is that right? I think that's right. He won the Nobel Prize for Literature, didn't he? I believe he won the Nobel Prize for Literature. Anyway, Bob Dylan is still alive. This guy who votes for Bob Dylan every time, I think he would say, I'm just protesting against the system, man. I know this vote doesn't matter at all, but I am making a public declaration of the fact that I don't like, the Trump and the Biden. I want to vote for an outsider or something. Voting for an outsider in a system which uses the plurality system is throwing your vote away. All right, the effect of this is this makes the D and R parties invincible. Right? There is really almost no way that anybody else could become the president in the United States because there is a huge disincentive for voting for anyone who's not in one of these parties. Now, a lot of people, pretty much everybody in America understands this and realizes that basically American politics is a game between the Republicans and the Democrats. And what they tell us ends up being what are the hot button issues in our society. This makes the Democrat and Republican parties invincible because nobody is going to vote for anybody outside of those parties anyways, even people who don't like either. Like I personally, I don't love the Democratic Party or the Republican Party, but you better believe every election I vote for one of them, even though I don't really like them, because I understand that mathematically my vote is not worth anything if I vote for Nader or Bob Dylan or something else. All right? It makes the DNR parties invincible. Now, people will tell you that's just the way the world is. That's how it is in a democracy, that you have to deal with the two political parties. I would say to those people, this is not caused by democracy. That's not just that's the way it is in a democracy. This is because we use the plurality system. Right? If you have ever sort of been disappointed to yourself about the fact that American politics is dominated by the two parties, this is not just a fact of life in democracy. It is a fact of life in a democracy if you use the plurality system. That's why the system exists. That's why the two-party system exists. It's because we use plurality when we vote. Actually, this is an often discussed fact among political scientists, which I'm not a political scientist, but they have a name for this. I'm sorry, I don't know how to pronounce this person's name. This is some political scientist, Duverger's law, I will say. This says that any political system, this is a law in political science. It's not like a law of physics. It's not 100% true, but it's generally true in societies around the world. Any political system, political, I'm trying to spell correctly. Any political system using plurality will eventually degenerate into a two-party system. this is a general fact which is true over in the world. And probably you know it, like if you know something about early American history, the United States did not begin as a two-party political system. And in the early days, there were many different political parties. There were changes in the structures of political parties. The Democrats and the Republicans were kind of like one party, and there were... This all happened in the beginning, but after a certain amount of time, things coalesced into the two parties, and then once that happens, it gets like locked in place, and there's no way to break out of it, because nobody's going to vote for, we have something called the Green Party, but nobody's going to elect a Green Party president because they're like nader, they're outsiders, and everybody knows they can't win, and so nobody's going to vote for them. All right, this is because of the plurality system, and actually politicians play games with this. This is something that that Donald Trump understands. I don't know if he consciously understands this, but he plays this very well. Trump, when it comes to elections involving Donald Trump always consistently says, I'm going to win, regardless of what the polls say or anything. They ask him, how are you feeling about the election? He says, I'm going to win. It's going to be a blowout. It's going to be the greatest victory ever. That's what Trump always says about himself. This works in a plurality system because you can get people to vote for you just by convincing them that you're going to win. Because people know nobody should vote for the loser. That's how the plurality system works. And so I can actually convince you to vote for me just by telling you that I'm going to win. Not that I should win or that my opponent should lose, but just by saying, oh, you can't vote for that guy because he's going to lose. You got to vote for me because I'm going to win. You got to get on the Trump train, right? All of that language about like, you got to like join the club, all of this kind of insider-outsider language, this is part of our politics because we use the plurality system. It's sort of impossible to overstate, in my opinion, the effect of all of these things. This is not just how democracy works. This is how democracy works when you use the plurality system. All right. Anyway, this is my little political ramble. Anybody have any feelings about this? I don't mean to just tell you all my own opinions all the time. I'm happy to hear your opinions. To me, this is what is the most interesting about just imagining, what if we changed our elections, if we stopped using plurality but used ranked choice for everything? I think this would have deep and huge effects on the way that our politics works. After a while, when people realize that, for instance, in the ranked choice, you don't always have to vote for a winner, that has a huge effect, in my opinion, right? Even if your favorite candidate is going to lose, you can still vote for them, and your vote will still count for your second choice. Yeah? Why don't we use ranked choice? One reason, I think, because it's good. It's too good for America. It's like, why don't we have free healthcare? That's too good for us. Yeah. No, I think So one good reason is ranked choice as a concept has existed for a very long time, but it is mathematically kind of a pain to compute the result. If you're using a computer, it's easy to do. Like if you ran, say, a U.S. presidential election using ranked choice, it would be mathematically harder to figure out who the winner was. If you're using computers, this doesn't matter at all. But I think this is why, for instance, I think this may be a big reason why we didn't use ranked choice like 200 years ago. Now, in modern times, it's easy to use ranked choice. I think there are political obstacles to doing it. If you look at politics as it exists right now in the United States, generally Democrats would like to use ranked choice and Republicans think it's a scam, or they say it's a scam. I don't know if they really think this, because it's not a scam, not mathematically, but they will tell you the ranked choice is just the latest scam by the Democrats to steal elections. This is part of a bunch of bogus rhetoric, but yeah, I would say it's a political issue. I think all parts of the political issue are influenced by the fact that ranked choice would probably make the Democrats win more and the Republicans win less, which means no matter what the reasons are, the Democrats are going to be in favor of it and the Republicans are going to be opposed to it. I should also say I'm not an expert in American politics, so please take whatever I say take with a grain of salt. All right. Okay. What do I want to say next? I would like to let's just put aside the ranked choice for a little bit. I would like to look again at the Bush-Gore Nader thing, and another way of looking at this election. And we're going to get to our next voting system. You know, we have the plurality system and ranked choice, but there's other ways to do it actually. And this is what prevents me actually. I kind of like the ranked choice better than plurality in the real world. But I'm not really a ranked choice booster. You know, I don't love the ranked choice system because there are other mathematically sophisticated systems that you can use that basically nobody in American politics is aware of. They're not talking about anything else because they're fixated on ranked choice. But there are other systems too. In my opinion, there's not a big reason to love the ranked choice versus some of these other things. So here is the Bush-Gore-Nader tally again. Nader, Gore, Bush. All right. And one thing that I said, you know, to me, the compelling reason why Gore should have been the winner in this election is what it looks like if you compare only in pairs. We've done this a little bit in the past, but I would like to look at here, considering only Bush versus Gore. What happens if we consider this election without Nader, only Bush versus Gore? Well, then we can see the people in the first column prefer Bush, and the people in the other two columns both prefer Gore, right? In these columns, Gore is above Bush here. Here, Bush is above Gore. So considering only Bush versus Gore, Bush would have 2.9 million. Gore would have 2.9 plus 0.1, which is 3.0, all right? So if we consider only Bush versus Gore, Gore would be the winner. This is why, in my opinion, Bush should not have, according to the rules, Bush was the winner. But in some kind of abstract sense, I don't think it makes sense for Bush to win an election like this because actually more people liked Gore better than Bush than the other way around. So why would you make Bush the winner? But anyway, if I consider only Bush versus Gore, then Gore is the winner. But there are other two-way comparisons I could make. What if I consider only, let's say, Bush versus Nader? Then who would have been the winner if it was only Bush versus Nader? Well, in that case, this is something that this kind of pairwise comparison is going to be like a major theme for us. So this is the kind of thing that we're going to do a lot. What if I consider only Bush versus Nader? I would have, in the first column, Bush is above Nader. In the second column, Bush is above Nader. In the third column, Nader is above Bush. So for Bush, it would be these guys plus these guys. So that's 2.9 million plus 2.9 million, which adds up to 5.8, I believe. 5.8 million people prefer Bush more than Nader. And then just the people on the end, the last column, prefer Nader above Bush. That's 0.1. So in this case, Bush wins. All right? Not a surprise. Not a lot of people actually wanted Nader to win. So if you compare either of the other two big parties to Nader, Nader does not come up very well. So Bush versus Nader, Bush would have won. What about Gore versus Nader? This is the other way that I could compare them. In that case, it's similar. The Gore would win in the first two columns. Gore is above Nader, and in the last one, Nader is above Gore. So here, the Gore would get 5.8, and the Nader would get just 0.1. And so Gore wins, all right? And something to notice here is that if you look at these comparisons, so Gore is the winner of one of them, Bush wins the other, and Gore wins another one. Wouldn't it be nice if Gore won all three of these? That would be sort of the ultimate flex for Gore to say, I would win any of the comparisons. Actually, it doesn't even make sense to say, could Gore win this one? Gore isn't even a part of this one. So this actually is the best possible outcome that Gore could have got if you consider only these pairwise comparisons. Gore wins, here let me say it this way, Gore would win every pairwise matchup. All right? if you only considered Gore with one other person, no matter who it was, Gore would be the winner. The only reason Gore lost the election is somehow because all three together, Gore was not judged to be the winner when they were all three together. But if it was just one-on-one, Gore would be the winner in every pairwise matchup. Can I just say, you might say, well, he wasn't the winner of this one. That's because there was no Gore in there. That wouldn't even make sense. So Gore would win every pairwise matchup involving Gore. Obviously, Gore cannot win Bush versus Nader just between the two of them. Gore would win every pairwise matchup involving Gore. All right? This is a very strong sort of statement about how powerful Gore was in this election, or how popular he was in this election. And this idea leads to another way of deciding elections. So rather than doing the plurality or the ranked choice, we could instead look at the pairwise matchups and find the person who wins all of their pairwise comparisons. This is our third voting method that we're going to talk about. So there's a name for that, for this method. So this is also named after this guy that I mentioned once last time. So this is a candidate, who would defeat every other candidate in one-on-one matchups. Such a candidate is called the Condorcet winner. Condorcet is a person's name. We mentioned them last time. We talked about something called the Condorcet paradox. This is the kind of thing that Condorcet thought about back in the day, and we, in honor of the man Condorcet, we call this a Condorcet winner. If there is a candidate who would have won in any one-on-one matchup against anybody else, they are called a Condorcet winner. So in that election in the year 2000, Gore was the Condorcet winner. Now that doesn't mean you're going to win the election. As we know, Gore lost the election, but we say the phrase Condorcet winner means they would have been the winner in any one-on-one comparison. If you compare just Gore versus Nader, Gore would have won. And also if you compare just Gore versus Bush, Gore would have won. That's called the Condorcet winner. All right? I have a little, a nice fact about this. I have been saying both times, I said the Condorcet winner. It is a fact, actually, that there can only be one such person. And I want to write this down. I want to try to explain this. I'm going to write this as a theorem. This may be our first theorem that we've talked about. I hope you're familiar with this word. A theorem is just like a true fact, which can be mathematically stated and also mathematically proved. So a theorem is a true mathematical fact which you can prove. And the theorem that I want to talk about is just the fact that there cannot be two different Condorcet winners. In an individual election, there can only be one Condorcet winner. I'll just say there can't be two Condorcet winners. All right, and I want to talk about the proof of this. We're not going to do a lot of theorems and proofs in this class, but every so often we will, because that's really what mathematics is all about. There cannot be two Condorcet winners. We can prove this. Remember, Condorcet winner means that it's one person who would have defeated all of the other people in one-on-one matchups. We're going to do, this is a common type of argument in mathematics. Since I'm trying to prove that something cannot happen, I'm trying to prove that there cannot be two Condorcet winners, I'm going to do what we call a proof by contradiction. You imagine that this could happen, and then you somehow explain why that's impossible. So I'm going to say, imagine we had two Condorcet winners. Let's say I'll just call them X and Y. All right? that it's two different candidates that we are imagining they're both Condorcet winners. That means that each one of them, they will win every comparison that they have with every other opponent. Can anybody explain why this is impossible? There's something like logically wrong with this. Yeah.
I mean, if, for example, X would win against every other
Candidate. Yeah.
He would also win against Y.
Yeah. Right.
So they cannot be like physically two winners because they have to win against each other.
Yeah, right. Yeah, exactly. X and Y, if we imagine they're both Condorcet winners, that means they always win against everybody. But, of course, they have to face each other at one point, and they can't both always win if they're going to face each other at some point. All right, so that's what I'm going to try and write something like that. This is what she said. So I will say, imagine we had two Condorcet winners, and let's say it's X and Y. Then, in the comparison, X versus Y, one must lose, right? They can't both win. I mean, let's just say I'm not considering ties. Can I say they can't both win? So both cannot be the Condorcet winner. All right. So there is only one Condorcet winner. There cannot be more than one. All right. That's the end of the proof. Mathematical proofs don't have to be like using a bunch of equations or whatever. It's really just explaining why something is true. And you know, most mathematical proofs are written in ordinary words and sentences like this. You will notice I used real words with punctuation and so on. All right. This leads us to our third voting method. We had the plurality, the ranked choice. This is called Condorcet's method. And I guess this is the third thing on our little checklist of topics. Condorcet's method. So this is another way to decide the winner of an election like this. What you do is you compare all of the candidates in pairs. Compare all the candidates in pairs. You find the Condorcet winner. This is the one who would have won against all of the other ones in all of the one-on-one matchups. Find the Condorcet winner, and you make them the winner of the election. This is called Condorcet's method. All right. This is not the same as plurality. It's much harder to do this than plurality. I mean, like mathematically speaking, to do all the comparisons takes you a while. It's also not the same as the ranked choice, which is about rounds. This is not about rounds. This is about one-on-one comparisons. This is called Condorcet's method. All right. So, for example, I mean, I want to do a few simple examples of this. In the Bush-Gore-Nader election, Gore would have won using Condorcet's method. That's what I've been saying for the past little bit. Gore would have won using Condorcet's method. Because Gore, when you compare them in pairs, Gore would have beat Bush, also Gore would have beat Nader. So that Gore would have been the winner using Condorcet's method. All right? Yes?
But isn't it then the same as the ranked choice system, but you just without the different rounds?
It is not the same. It's similar, and in that particular example, Gore would have won with the ranked choice, and also Gore would have won with the Condorcet. But actually, there are some examples where it's not the same. So actually, we're going to do another example right now. Let's just see how it goes. Typical like homework problems about the Condorcet's method is like I show you an example election and you figure out the winner using Condorcet's method. So let's use the one from this paper again. I'll just write it again here. There were 14 people, say A, B, C, D. 10 people say C, B, D, A. 8 people say D, C, B, A. 4 people say B, D, C, A. And 1 person says C, D, B, A. All right, I'm going to use find the winner using the Condorcet's method. All right. So what we got to do is compare all of the candidates in pairs. And unfortunately, there are kind of a lot of ways that you could pair them up here. There are 4 options. I'm going to try to write them in some kind of systematic alphabetical order. I could do A versus B, or I could do A versus C, or I could do A versus D. Those are all the pairs which involve A as one of them. Then I could do B versus C, or B versus D. Those are all the rest of the pairs which involve B. And then there's one more choice, which is C versus D, right? And I need to do all of the comparisons in all of these cases. Unfortunately, this will take you a minute or so to work it out. It's not hard. It'll just take you a few minutes, all right? Let's see if we can do it now. A versus B. Okay, I'm going to say how many votes for A versus how many votes for B. So what I'm doing here is look at the whole chart, but right now, at this point, I am only considering A's and B's, and I'm counting up how many people like A better than B versus how many people like B better than A. So let's count up how many people like A better than B here. It would be 14 people here. And then I'm looking at all these columns, but they do not like A better than B. So it's only 14 people like A better than B. And then in this case, everybody else likes B better. These people like B better. B is above here. B is above A. B is above A. So I have to add up those numbers. 10 plus 8 plus 4 plus 1. This adds up to 23 people who like B better than A. And so in this comparison, B is the winner. Maybe I'll just circle the B there. Is there a question before? All right. B is the winner if you consider only A versus B. And now we have to do this 5 more times. I know it's a little bit of a pain. Again, in the real world, you use a computer for this and everything is easy. But it's not so hard, right? A versus C. So again, I am going to keep track of how many people like A better than C and how many people like C better than A. You have to count up here. It looks like these people like A better than C. That's 14. And who else likes A better than C? Actually, nobody else, right? Everybody else likes C better than A. So this is just 14 for A on top. And C, everybody else likes C better than A. So this would be, again, all the other columns. I have to add up 10 and 8 and 4 and 1, which is 23. All right, so here C is the winner. Yes?
Sorry to interrupt, but
No, it's fine.
if you know that A can't be the Condorcet winner, could you just then do B versus C just to see if...
This is a good idea. Yeah, once you've done this here, you already know A is not the Condorcet winner. So it comes down to checking if B or C or D are the Condorcet winner. But actually, you're going to still have to do this when it comes to telling if C is the Condorcet winner. So actually, the fact that B1 here, you're still going to have to do all of them anyway. Yeah, unfortunately. It's a good idea, though. But yeah, you still need to do these checks to make sure that, like, eventually I have to tell if C is going to beat A and also if D is going to beat A, even though I know A didn't beat B. All right. Great. So C is the winner in this comparison. What about this one, A versus D? Can anybody see what's going to happen there? Yeah?
Be the same thing.
Yeah, it's the same result. You can see because A is always on the bottom here, D will also beat A in the same way. So this comparison, still A gets 14 and D gets everybody else 23. D is the winner there. All right, let's do these 3. These are a little bit more interesting. B versus C. So B versus C, I have B's and C's. I'm going to have to look a little bit more carefully this time. How many columns have B above C? That would be this 14 likes the B. The next column, they put C on top, right? This column here has C above, so those 10 votes go to C. The next column has C above B. So these 8 votes go to C. The next column, the 4, has B above C. Oops. The B is above the C right here. So these 4 votes go to B. And in the last column, C is above the B. That's 1 more for C. This adds up to 18. This adds up to 19. C is the winner. All right. What about B versus D? Same idea. Actually, at this point, no, I was going to say we don't have to check this because we already know B is not the Condorcet winner because B lost here. But actually, D might be, so we need to check this. B versus D. Same old thing here. We're just doing the same thing over and over again. B is above D in the first column, so that's 14 to B. In the next column, B is above D again. That's 10 to B. In the third column, D is on top, so that's 8 to D. In the fourth column, right here, B is above D, so that's 4 points to B. And in the last one, D is on top, that's a 1. So this is 9 and 28. B wins this comparison. And finally, C versus D. I hope you agree with me. This is kind of easy, but it takes you a little while to do. It takes me longer because I'm trying to shout out as I do it. In the first column, C is above, so that's a 14 for the C. In the next column, C is above, that's a 10 for the C. In the third column with the 8 up top, D is on top, so that's 8 for D. In the fourth column, D is above C, so that's 4 for C for D. And in the last column, C is above D, that's 1 more. So this is 15? No, 25 and 12. So C is the winner. All right. This is all the work, all the hard work has been done. Now you just say, who is it? Is there one which wins all of their own comparisons? Now, obviously, nobody wins all 6. That's because you can't win all 6 because you're only involved in 3 of them. Is there anyone who wins all the ones that they are involved in? What do you say? Yes, C is the Condorcet winner. C was the winner in all of their own matchups. So C wins every one of their comparisons. Is it possible that someone else could also win every one of their comparisons? No. Could we just prove that there's no way that there cannot be 2 different Condorcet winners? So there's only one. It's C in this case. So C wins with the Condorcet's method. All right. And this, can I just refresh our memory? When we did the plurality in this same example, the plurality makes A the winner, and the ranked choice, it was B, wasn't it? I think we did this at the beginning of class today. The ranked choice winner was B. And here, the Condorcet winner is C. So the moral of the story is the Condorcet's method really is different from the ranked choice and the plurality. All right? Is it better than the plurality or the ranked choice? At some level, my answer to these questions about which one is the best is like, oh, I don't know. I mean, I don't know. It's just different, right? It's up to you to decide if you think this is a better way to do it than those other ways. All right. Any questions about that? I hope it's clear how we do it. All right. How about I got another example? Let's just try one more example. In the real world, like I said, the issue of using plurality versus ranked choice is kind of a hot topic in America these days. Nobody ever talks about Condorcet's method, though. Actually, there are legitimate reasons why people don't use Condorcet's method in the real world. And if you ask me personally, it's not even a personal opinion. Condorcet's method is not a good idea to use in the real world. Nobody actually campaigns for this, and this next example shows why. Let's say, this is another made-up example. Let's say 12 people voted ABC, 8 people voted BCA. I'm going to have you guys write this down on your paper and see if you can work this out. I'm going to walk around and see how you're doing. All right. Find the Condorcet winner. In this case, there are only 3 candidates, and so you only have to do 3 comparisons. There's A versus B, there's A versus C, and there's B versus C, right? I'm going to try and do this, probably every day during the semester. I'll give you something to work on. I'm going to walk around and make sure you're doing okay. I'm not trying to give you a grade or anything, so I hope you don't mind. I will walk around and try and help out. But if you have questions, please let me know. If you don't want to talk to me, that's fine too. I'm here to help. I'm not here to judge you. Not today, at least. On our test days, that's when I'm here to judge you. But not today. Can I just point out, in this election there are 29 total voters. That is, if you add the numbers up across the top, there's 29. It means, just make sure, in all of your comparisons, there should be 29 votes total. Some of them like A better, some of them like B better. If the numbers are not adding up to 29 every time, it means you are missing some. All right? Yeah. All right.
Oh, because it's a paradox.
Is there really a Condorcet winner that loses in another type of voting?
Yeah. Like in this example, C was the Condorcet winner, but A was the plurality.
Oh, plurality.
Yeah, he is the rank choice. So you can, they're all just totally different. All right. Yeah, so I'm looking at, if you look in each column, you ask, how many of these people are A there? So these 12, they're A there. These ones are A there. So that's 12 people here are A there. And 7.
There is none. There is none.
Let's not give away the answers. Right?
Oh, I'm so sorry. I'm so sorry.
All right. I did say this is actually an example demonstrating why this method in general is not suitable for using in the real world. It's true. That's why nobody wants to use Condorcet in the real world. You good? All right.
Yeah.
Yeah, so now you're going to just figure out who's the winner in all of their checks. Here we looked at what does it seem is going to fall. All right, it looks like most people are working it out. I didn't work out the numbers, but can somebody just shout out, in A versus B, who was the winner? A. And in A versus C, it was? C. And in B versus C, it was B. Yeah, I think this is correct. I hope that, did anybody disagree with that? I think this is what it is. So, who is the Condorcet winner? That is there somebody who wins in all of their one-on-one matchups? The answer is no, there isn't. A lost once, A lost here, B lost once here, and C also lost once here. So in this example, there is no Condorcet winner. And this is the principal reason why nobody uses the Condorcet method in real life, because often there is just no winner. So if you were doing this in real life this way, you would just have to say, like, I guess it's a tie or something like that. There is no Condorcet winner. Of course, if people use the plurality system in the real world, and in theory, it is possible to get a tie in the plurality system, but a tie in the plurality system is, statistically speaking, very, very unlikely. Whereas in the Condorcet method, actually, this is not very unlikely. This happens often in Condorcet's method, that there is no Condorcet winner. So I will say, often, Condorcet's method does not choose a winner. And it's not like, yeah, technically you can get a tie if there's some kind of absurd coincidence occurs. No, like it doesn't have to be an absurd coincidence. In a normal situation, it is not unlikely that this would happen. So often Condorcet's method does not choose a winner. So we don't use it in the real world. We don't use it as a method in real elections. It's still important, like as a theoretical idea though, because for example, you can say in the Bush-Gore-Nader election, you can say, I believe that Bush shouldn't have been the winner because Gore was the Condorcet winner. That's still a statement which makes sense, even if you don't actually use Condorcet's method in real life, because it's not appropriate for using in real elections, because sometimes you just don't get a winner. But the Condorcet method as a concept is still an interesting and helpful way of analyzing, elections in terms of the pairs. It is not suitable for use in real political systems, though, as a method. All right, this is Condorcet's method. Any thoughts about that one? That is our third voting method. We got 17 minutes remaining. Was that a question?
First test?
I don't remember. It's on the syllabus.
Okay.
Yes, when's our first test? Is it next week? It could be next week. We're having frequent exams in this class. I got the syllabus here. Let's look it up.
February 10th.
February 10th. All right, thank you. Not next week, right? That's the week. 2 weeks. A little something to look forward to. All right? In our remaining 16 minutes, I think we can talk about one more voting method. And this one actually is suitable to be used in the real world. It is not often, but at least it makes sense. You can use this method in the real world. Another method. It's called, this again is just named after a person, the Borda count. This one actually is used fairly often to do things in the real world, although not very often used in politics, but it is used in other settings, which I will give you some examples once we describe what it is. The Borda count, this is actually a fairly obvious method in that, like, if you ask a room full of kids to just like invent their own voting system, probably some of them will come up with something like the Borda count. And I think even someone on the first day shouted out some method like this. When the Borda count is all about each ballot gives points. So you make it so that, like, if someone's listed in first place, that gets you 10 points. And then the next place down, maybe that gets you 5 points. And then at the end, you add up everybody's points, and that's how you decide the winner. This is called the Borda count. Each ballot gives points, and then the winner is the one with the most points. Now, we have to be specific about, okay, how exactly do the points work? But this is the basic idea. Each ballot gives you points, and the winner is the one with the most points. All right. And here's the way that the points work specifically. So, specifically, how to get points. Last place, last position in the ranking, A, B, C, D, whatever. The person ranked at the bottom, last position gets 0 points. And then the second to last gets 1. And then, the third to last gets 2, etc. The top position, therefore, gets, so if there are n options or n candidates, the top choice gets n minus 1 points. All right. If you have a ranking that looks like A, B, C, D, something like that, then the points go 0, 1, 2, 3. All right. It's always 0 at the bottom. I don't know if it looks confusing what I said up there. It's not actually confusing. It's always 0 at the bottom and then 1, 2, 3 going up the side. All right. If there's n candidates, the top choice gets n minus 1 point. So in this little example here, there were 4 options. That's why the top ranked position gets 3 points. 3 is 1 less than 4. All right. This is how the Borda count works. It's a very simple idea, and it's not all that hard to figure out the winner, although you have to, unfortunately, do a whole lot of simple arithmetic, which I am not personally into simple arithmetic. But here's an example. How about, let's say one person votes A, B, C, D. Another one person votes B, A, D, C. And then another one person says C, D, B, A. All right? Who is the winner using the Borda count? So I will just write out the points for my own reference. Go like this. 0, 1, 2, 3. All right? And we have to add up the points for each of these 4 candidates. How many points does A get? So here's what you got to do. You look at the chart here. I see A here. 1 vote for A, getting 3 points. So that's a 3. Plus, in the second column, A gets 2 points. So that's 2 more. Plus, in the third column, A gets 0 points. So that's 0 more points. For a total of 5 points for A. All right? You look column by column, and you add up how many points that person got. I hope everybody sees how I'm doing this. How many points does B get? All right, in the first column, B gets here 2 points. That's 2. Plus, in the second column, B is on top. They get 3 points for that. And then finally, in the third column, B is in this position getting 1 point. So this is 6 for B. All right? All right, do you agree this requires some amount of simple arithmetic? I actually prefer abstract mathematics rather than doing this kind of stuff. I'm likely to mess this up just as often as you are. I mean, I'm not any better at this than you are. C gets 1 point in the first column, 0 in the next column, 3 in the next one. So this is 1 plus 0 plus 3, which is 4. And then D gets 0, 1, and 2. 0 plus 1 plus 2, which is 3. The winner is B. B wins with the Borda. All right? This is the Borda count. There's not a lot to it. I mean, it's a simple idea, and how you do it is, also simple, although be careful with the numbers so you don't mess it up. Any questions about that? This is the Borda count. Now, this actually was an easy example. A more typical example will require, unfortunately, there's some adding, but actually a usual Borda example requires some multiplying. Can you handle a little bit of multiplying?
No.
Yeah, I'm not sure myself. I mean, about myself. I have confidence in you all, though, that you are experts. Can you multiply things like 3 times 2? I hope that you can. All right. This, by the way, I believe this is the only time in the entire semester when you have to multiply is when we're doing the Borda count. So get it while it lasts. If you like multiplying, today is your day. All right, those are the points, right? Now, what's different about this example is these numbers up top, all right? You have to take into account these numbers up top. So what this means is in the first column, A got 2 points, but there were 3 people who voted that way. That means A gets 2 points each from 3 different people, which is to say, actually, it's 6 points. I'm going to write this out as 3 times 2 from the first column. And then the next column is 2 times 0. That's because the first column, there were 3 people that gave A 2 points each. And in the second column, there were 2 people that gave a 0 points each. That's why it's 2 times 0. All right. And now, when you are adding this up, of course, on a homework or something, I would encourage you to use a calculator. But you better be sure that you do the order of operations correctly. If you just use your simple, iPhone calculator and type this in as written, you'll get the wrong answer because of the order. You got to multiply first and then add. So this, I would, if I were doing this, which I am, I suppose, I would multiply first. That's 6 and 0. And then that adds up to 6. All right. Do the multiplications first and then the additions. Maybe it's a little clearer. Actually, I'm going to do it like this. I'm simplifying in that first step. That's a 6, that's a 0, and it adds up to 6, right? Okay. Next, B, all right? B has 3 people in the first column, gives them 1 point each. So I'm going to write that's a 3 times 1. And then in the second column, 2 people, 2 points each. That's a 2 times 2. This is 3 times 1 is 3, plus 2 times 2 is 4. That's 7. All right. And finally, the C gets the C gets 3 times 0 plus 2 times 1, right? That's 3 people give them 0 points, 2 people give them 1 point. This is 0 plus 2, which is 2. And so B wins using the Borda. All right. Exclamation point. I notice that a lot of people feel compelled to put an exclamation point every time they say who wins. Go for it. That's what I say. All right. We have a few minutes left. I just got one more example to try. Can we look at the Bush-Gore Nader and see who would win that one if we use the Borda? So with plurality, Bush was the winner. That's how it really happened. But with ranked choice, Gore would have been the winner. Also, the Condorcet would have chosen Gore. Let's look at Borda. So I want to do the Bush-Gore Nader with Borda. I actually read a history article, a research article by a historian, where he claimed that the American Civil War would not have happened if we used the Borda count for presidential elections, because apparently there's evidence that Abraham Lincoln would have lost the election if they used the Borda, which would have made all of the history about the Civil War would have been quite different without Abraham Lincoln. They weren't saying it would have been better, but it would have made a difference. Anyway, the Bush-Gore Nader using the Borda. So I will again write these number totals. We had 2.9 million people said Bush, then Gore, then Nader. 2.9 million said Gore, then Bush, then Nader. And then 0.1 million said Nader, Gore, Bush. All right? Can we add up using the Borda? So again, the points go like this: 0, 1, 2. And we have to add up in the same way. What does Bush get? It's here. Bush is getting 2 points each from 2.9 million people. So this is 2.9 times 2 from that column, plus in the next column, 1 point from 2.9. So this is 2.9 times 1, plus the last column is 0. 0 times 0.1. And this, if you add them up, I don't know if you're into adding decimals or whatever. I added this up ahead of time. I got 8.7. That's not really hard to do, but Bush gets 8.7 million Borda points. All right. What about Gore? Gore is 1 from this column. So that's 2.9 times 1 plus the next column, 2.9 times 2 plus the last column, 0.1 times 1. This adds up to 8.8. Actually, this is the same if you compare these two numbers between Bush and Gore. It's the same stuff, only right here. Bush got a 0.1, Gore gets a 1.1. All right, 8.8. And then Nader, it's not a shock. Nader is not going to win this one. It's 2.9 times 0 plus 2.9 times 0 plus 0.1 times 2 for a total of 0.2. All right? Nader is never going to win these elections. But anyway, Gore is the winner using the Borda. Gore is the winner if we use the Borda. All right. Can I tell you one? So I said before that Borda is very rarely used in real political elections, and we're going to talk a little bit later about why that's the case. But Borda is used in informal type elections all the time. And the example that I am most familiar with is in a competition which you may be familiar with called Mario Kart. You may know that when you play Mario Kart, usually you're playing the Grand Prix mode. You do like 4 races, one after another, and after each race, depending on where you finish, you get a certain number of points. And it's basically like the Borda points, although Nintendo doesn't want you to feel bad, so they don't start with 0, they start with 1. Even if you lose, you still get 1 point. But it's true. But anyway, you get the points, and then at the end, they add up all the points, and that decides who gets the trophy or whatever. So those kinds of situations, the Borda is very popular. Not so much in politics. All right, I think that'll do it. Let me know if you got homework questions. I can hang around right now for a little bit to chat about the homework if anybody wants to. Otherwise, send me an email or something. I'll see you Friday. Don't forget to submit it. It's due tomorrow night.
Thank you.
Mm-hmm.
I just have a quick question about the homework.
Yes.
For number 3.